Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 22, which reads, it is proposed to generate a microwave signal by feeding the output of a UHF transmitter to a frequency multiplier circuit. This arrangement is suitable for use with A. Amplitude modulation, B. Single sideband modulation with suppressed carrier, C. Frequency modulation, or D. Single sideband modulation with a pilot (brackets reduced) carrier. So a frequency multiplier does just that, and it multiplies its input usually by a predetermined factor, and that allows you to achieve an output perhaps on a higher band, and that works really well when you've got bands that are harmonically related. For example, you could multiply an oscillator you were using for the 40 meter band to work on the 20 meter band. And the full license manual does actually have a section in it about the frequency multiplier with a couple of examples of how they work. We've got this one on the left, which I think is designed to work with an oscillator stage in a transmitter maybe, and we've got this tuned circuit on the input, and then the output of that tuned circuit is driving this transistor, which is deliberately being overdriven so that the output is distorted. And when we have distortion, that creates what we call nonlinearities or harmonics, and then this tuned circuit on the collector is being used to select the desired harmonic. So we may have an oscillator that works for the 40 meter band. We drive this transistor into distortion, and we get the third order harmonic would be 3 times 7 gives us 21, which might be just right for working on the 15 meter band. Over here on the right, we've got a slightly different one. This is what's called a varactor diode multiplier for the 10 gig band, but it works broadly on the same principle, where we've got this device here, the diode, which is basically being driven into distortion, and that's going to again create nonlinearities and create harmonics. And in this case, we're on 10 gigs, where it's much more practical to use waveguides for selecting the desired output. And I mean, what's quite interesting about this circuit, as the manual talks about, you have sort of 2 watts of input at UHF, and it generates a few milliwatts at 10 gigs. But we're not going to go too much into the details of this just yet, because this question is asking us about the different modes that we can use with it. So, as we've discussed, these frequency multipliers work on the basis that we are deliberately causing distortion, and that's going to create nonlinearities that we can then select. They're going to be multiples of the input, and those nonlinearities are going to have distortion in amplitude, and that's going to mean that anything that relies on amplitude modulation isn't really going to survive that process. On the other hand, frequency modulation, or basically the frequency information, is going to be more or less preserved. One of the effects of multiplying an FM signal is that the bandwidth is increased. It has an effect on the modulation index, but the actual information, the encoded information within that signal, comes away unscathed. So let's put a marker by frequency modulation, and what else have we got? We've got AM, amplitude modulation. That is not going to work because the amplitude is going to get distorted. It's not going to survive that process well. Single sideband modulation is effectively amplitude modulation as well. That's not going to work. We've discussed that frequency modulation could work, and we've got single sideband modulation with a pilot, which is also amplitude modulation. That's also not going to work. So that leaves us with option C as our most reasonable answer. Again, so let's skip down to the answers, see if that makes sense. And yes, we can see that for question 22 we've got option C. So the key thing to remember here is that certainly within the full syllabus, that it's only really FM signal that can get through a frequency multiplier. If you're interested in this, you can go read up on it. You'll find that there are ways of doing this with amplitude modulation as well, that allows AM or sideband signals to get through it to be multiplied up, but for the full, just bear in mind it's only FM that can make it through. Thank you very much. I'll catch you for the next one.